And gentlemen, as chair of the COM 2014 and on behalf of the organizing committee, I welcome you to Vancouver and to the conference. Even in difficult times such as these, which we are all aware of, it's important to meet face-to-face to discuss technical issues and challenges, to establish and renew contacts. And the world is realigning, and the metallurgical landscape needs to realign with it. So the programming at MetSoc is trying to address this a little bit beyond just the technical symposia by having events on risk management, which follows this, the role of societies in the profession, which also follows this one, and this plenary as well. So the goal of these events are to stimulate discussion that could move beyond the actual event and maybe even beyond the conference, and I hope that will be the case with this plenary. The last few years have been painful, to put it mildly, in our industry. Everyone seems to have an opinion why, in hindsight, project cost overruns occur or why new technologies fail. But really, for the industry to thrive and for confidence to return, investors have to have a sense that there's more good news than bad. We need to learn from our mistakes as well as our successes and transfer this information to the next generation. And so this leads me to the conference plenary that we have set up. I personally am an experimentalist, and I like running experiments, and this is one of my experiments. So we'll see how it goes. We'll try it out today. So this discussion that we have, debate if you want to call it, is based on the Monk debates that are held in Toronto annually, 2 people against 2 people. However, the topic that we have today, which is operational excellence versus technical step change, small changes in plants, making them better versus big new technologies coming in. It's not really a black and white issue. It's not one or the other. And so this will be more of a discussion about the appropriate balance between the two. The topic is especially current given the number of large capital projects that have experienced significant cost overruns in a decade. It's almost assumed now that you're going to have a cost overrun on a large capital project. So this has prompted companies in the last few years to look inward a bit and search for revenue increases through operational improvements instead of considering large capital projects or new technologies to retrofit in existing operations. There's been a bit of a shift there. But this reaction may not be the best for the long-term success of the industry. And so that's what brings us to this plenary, which offers a chance to explore the balance between the two. You'll have a chance to participate during this plenary. We'll have an initial discussion from both sides. Then we'll get into a more open discussion, just briefly. And then there are 4 microphones located around here. And as the discussion unfolds, if you have a question, could you please come up to the mic? And when we sense that the audience is primed, we'll flip it over to you, and we'll get a good discussion going on. Again, I would like this to go beyond this meeting, to go beyond today, for the conversation to spill out into the hallways, into the streets, and across the country, and for us to discuss this and get some benefit long-term out of it. So before I start, I'd like to introduce the speakers. Oh, we need the... There we are. So that's the welcome. Next slide, please. The next one. There we go. So Nils Vorman, during his 25 years at Hatch, Nils Vorman led the firm's metallurgical furnace group and then their technologies business unit. He now has executive responsibility for Hatch's business practices globally, including technologies, systems, consulting, environmental services, and operational performance. Under his leadership, Hatch maintains a strong pipeline of technologies in progressive stages of development and commercialization. He's a BSc from my alma mater, Queens, and an MBA from INSEAD. The next one, please. Jean-François Turgeon joined Tronox in January 2014 as Executive Vice President with responsibility for the global production and marketing of mineral sand, pigment, and electrolytic products. He started his career in research at Rio Tinto Iron and Titanium. He's a specialist in the TiO2 industry and the inventor of the UGS process to upgrade TiO2 content of slag. He has a bachelor in chemical engineering from Laval University and a master's in engineering from McGill. Philip Mackey is a consulting metallurgical engineer with over 40 years of Canadian and international experience in all aspects of the non-ferrous metals business, with particular experience in the copper and nickel industry. Since 2010, he's been president of his own consulting company, PJ Mackey Technology, Inc. He acts in a senior consulting role to a number of mining and metallurgy companies worldwide. And last is Mike Agnew. Michael Agnew has over 30 years of metallurgical project and operating experience as manager, executive, corporate director, and consultant. Since 2006, Mr. Agnew has been the principal of Michael Agnew, Inc., a process metallurgy consulting company focused on providing technology evaluation and selection, implementation and integration of innovation technologies, and marginal improvements of existing technologies. So we've got a great group of 4 people here to start off the discussion, and I'll ask Niels to start things off.
Thanks, Boyd, and good morning, everybody. If I could have the slides, please. Good, I'll get started. My purpose today is to argue the case for technological step change as opposed to operational excellence, which is being argued by my worthy opponents in this debate. Thanks. Of course, I won't argue against operational excellence. Nobody promotes operational mediocrity, after all. However, our key point is that there are limits to what operational excellence can achieve. After all, no plant can achieve availability above 100%. Only new technology can enable a significant step change in productivity, financial performance, or environmental performance. But the issue people have with new technology is fear of an unpredictably long schedule, a blown budget, and uncertainty about the expected benefits. Of course, there is some inherent risk with new technology, but we'll show these can be managed so that the desired outcome is achieved. No amount of operational excellence will make a horse-drawn cart as fast as a car. Even an exceptional operator cannot make his car go as fast as a plane. To get significant improvement in speed, more than operational excellence is required. Clearly, technological step change is needed and evidently embraced by most of us who didn't arrive by ox cart. You'll be pleased to know the rest of my examples are from the metallurgical field. This is the key graph from the well-known 1998 paper by Terry McNulty. His data shown here are from 41 metallurgical plant startups. The vertical axis is % design capacity achieved, with time in months on the horizontal axis. The data is divided into 4 series, as you can see. Series 1 at the top comprehends those projects using mature, well-proven technology with an experienced owners team in a first-world location. Series 2 to 4 represent projects with increasing levels of novel technology, with inadequate test work and often implemented without proper stage gates and reviews, and often built in remote locations. This graph shows that new technology is often messed up, clearly. However, it does not follow that the whole concept of technology step change is inherently flawed. Rather, I'd say it demonstrates the importance of risk mitigation. Terry McNulty is giving a paper here on Tuesday, and I understand the data in it support what I'm saying. Carefully developed and executed new technology projects can ramp up quickly, and I'll show a few examples of those. Here is another graph similar to McNulty's. Hatch, led by my colleague Bert Wasmund, recently conducted a survey of 23 new technology metallurgical plants, both hydro and pyro, started up over the last 15 years or so. This graph shows the same ramp-up production data similar to McNulty's, from all the projects examined in this assessment. Again, percent of design throughput rate is on the vertical axis, and time in years is on the horizontal. You can see there's large variability in the data when one plots the results for individual new technology plants instead of the average shown in McNulty's 1998 graph. From this disaggregation of the data, it's obvious that a significant number of new technology implementations had excellent startups. In fact, they were even better than the Series 1 average that is above the top curve in McNulty's graph that I showed a minute ago. Here are some examples. This is an example from the Pyromet area. It's the Impala Platinum converting process, and this project's demonstrated a ramp-up achieving Series 1 performance. That is full production rate 18 months after startup. Impala Platinum's converting process was started up to replace Pierce-Smith converters. The primary step change was in using a top-submerged Lance-type vessel for converting for the first time. Previously, the TSL process had only been used for smelting. It was recognized from the outset that converting is much more intense a process than smelting, so a robust test program was undertaken. This project contained a number of technological step changes. The first, as I said, was using the TSL process for converting instead of smelting. This required additional technological firsts. Copper waffle cooling elements were installed in a TSL vessel for the first time, and a furnace binding system was implemented on a circular furnace for the first time ever. The ACP started up and reached full capacity in less than 18 months. So this project demonstrates that technological step change can certainly result in a Series 1 type quick ramp-up, and it achieved environmental performance that no amount of operational excellence could achieve from the Pierce-Smith converters it replaced. The Koniambo ferronickel plant is another example that demonstrates the need for careful and complete risk mitigation to ensure a smooth ramp-up. This risk mitigation was done for the metallurgical plant with demonstration scale testing of each of the key unit operations. The whole metallurgical process is totally enclosed. It therefore has outstanding environmental performance compared to the traditional rotary kiln electric furnace process for ferronickel. The met plant at Koniambo works quite well. Ironically, the problem is the low-tech coal-fired power plant purchased from the low bidder. With reliable power, the met plant would likely achieve Series 1 ramp-up performance. A last example is from Impala Platinum in South Africa. Impala is known as one of the best operators in the platinum industry. But when they decided to increase production, they looked to technological step change. Instead of building more small furnaces, they chose to capture economies of scale by building one larger, more productive furnace. They achieved quick ramp-up to full production rate in less than a year. So they reaped the financial benefit of economy of scale enabled through a technological step change. So in summary, technological step change provides benefits beyond those achievable from operational excellence alone. A step change in technology enables a step change in outcome, and these outcomes can be environmental, as I showed, productivity, or financial, and ideally a combination of all three. Thanks very much.
So as we get set up for Philip's talk, I'll ask Mike to give his first impressions of Niels's presentation.
First impression, very impressive. We have worthy opponents. I might just mention for everyone, at this point, people might be thinking that operational excellence is the default position and happens when we do nothing all by itself. That's not the case. You have to work hard at it, and we'll like to show you that it's worth the effort.
Thanks. Philip?
Yep, thank you. Mr. Chairman, honored guests, honored colleagues, ladies and gentlemen. Mr. Chairman, I'm very pleased that Mike and I are here to debate with our honorable colleagues. We're talking about operational excellence. We could move to the next slide. What is operational excellence? Well,
I'm helping you, but that's the last time.
thank you. It's really the pursuit of doing things better. And really, do we have a choice? Do we all agree in the audience that our plants strive for operational excellence? Could we have a show of hands? We all agree. Thank you. So nobody disagrees. But we'll have a little bit of fun now. As part of this debate, some of us this summer visited a number of plants. We visited 4 plants across several countries, and it's a bit like a mining, metallurgical type, what I did this summer. So this is the essay. So we're describing 4 plants. We're going to call them Plant A, Plant B, Plants C, and Plant D. So our first visit was to Plant A. Now, Plant A was a large non-ferrous smelting room refinery. It was a well-designed plant, was about 20 years old, was kept in very good condition, well-maintained and clean. The plant manager, whom we met on arrival, he was pleasant, very hospitable, very helpful, and over a number of years he'd landscaped this plant. And we realized, why shouldn't a metallurgical plant look like a manufacturing plant as a very pleasant, clean place? At the plant, we saw that it was clean, good working conditions. Further, as we looked at the technical operating data, the metallurgical performance was at a very high level. The more we toured this plant, the more we could tell here was operational excellence. In a way, we don't need to ask what it is. You know it is when you see it. It's a bit like a journey. You know you've arrived when you get there. At Plant A, all the indices we looked at, like tons per day, on-stream time, health and safety, environment, metallurgical recoveries, inventories, maintenance, all were very good. Their costs were in the first quartile, as you see here, and the plant was very profitable. We realized the people at Plant A, they really understood the business they were in. The workforce was happy with their employer, and we noticed that they were not unionized. During our visit, we could see several innovative features. They had a new high-efficiency burner recently installed, and they were testing a new electrolytic tank design. They were actually working on incremental capacity, and these innovations were going to make sure that was a success. We found out from the plant manager that they have an R&D budget, and he told us that he insisted to the board that he keeps that budget. Not only that, he increases that budget year by year. We believe that the culture, if you could call it, began with the plant manager and the board, and he ensured that this was communicated throughout the plant. The staff we spoke to were enthusiastic about their work and the challenges, and clearly one could tell that the company had hired the top talent to work for them. They told us that a risk they had was the ability to attract and retain key employees at the plant. And they were actually looking at strategies to tackle this problem, including compensation, fringe benefits, and so on. Staff were encouraged to attend up to 2 conferences a year, And as part of that, they were asked to write a report and come up with two new ideas. We understand that that high-efficiency burner was a result of one of those activities. They were proudly telling us that for the $2,000 or $3,000 on that conference, they were probably going to save up to $500,000 a year. They get a consultant every 2 years to do an energy audit, and every time they said it pays off. So their energy consumption was coming down. Here we had a plant that clearly was operational excellence, but they were not stopping there. The plant manager said that they're working on a number of new improvements, and he didn't say what they were, to improve things. So, and as far as we could determine, they did not need to switch to a brand new technology then. We went to some other plants, but the one we're going to identify now is Plant B. Plant B was a different type of non-ferrous plant, but it was clearly a different culture to Plant A. Roughly about the same age, but Plant B could not be considered in the same class as Plant A. Technically, Plant B seemed to be somewhat behind. The plant manager, as dictated by his board, only wanted to push production. His costs were in the middle to lower quartile, and there was no evidence of an innovative spirit at the plant. The bonus was tied to production, and that was the overwhelming drive. They only were able to lower unit costs by increasing production. Safety was fair to good, but one could see areas of improvement as regards safety and health. We felt that their approach to cost-cutting can sometimes compromise safety. There was no R&D budget at the plant. Few or no one from that operation went to conferences, but we heard that the manager did go to one industry association event once a year. They didn't bring in consultants to do an energy audit. In fact, they hadn't even done an energy audit. They said the consultant was too expensive. Clearly, they didn't see the benefits. So in this plant environment, a step change to new technology wouldn't have worked anyway. On our trip, we visited Plant C. Now, Plant C was a completely different kettle of fish. It was clearly in need of an upgrade if it was to remain in business. It had seen better days, and management just wanted to push production. The safety record was not good, and they'd had some environmental violations. Not significant ones, but a worrying trend. Interestingly, this plant had changed owners in a merger and acquisition deal, and the new owners seemed to show little interest in the cost involved. Many aspects of that plant were favorable: good location, low energy, good transportation, and access to high-grade raw materials. There were excellent neighborhoods nearby to draw high-caliber staff. Prices for their product were rising. But we felt if a number of changes were made at this plant, including introducing a culture of operational excellence, the plant could be profitable. We don't know about the new owners, and maybe their intention was to eventually close this plant. That outcome would be a pity because it didn't have to turn out that way. Finally, we visited a company that are building a brand new plant. We're going to call it Plant D. And what a wonderful sight that you can see on this slide. But interesting, as we talked to the operators about the startup, they said that we have operational excellence embedded in the startup. So chances are that plant will be successful. So in closing, we visited these 4 plants. Plant A, as good as it gets. If not enough, e.g. environmental changes come along, they may need a step change, but they're in a good position to do it. Plant B needs operational excellence if it's going to survive, but they probably need a change in management approach as well. But we need to see how much improvement is possible and will it be sufficient. Plant C, it's really too late. Plant C, it's out of date, and it's a candidate for step change. Plant D, a brand new start. Greenfield site, New plant presently under construction. Culture of operational excellence has already commenced, and it'll be part of the startup, they told us. So in bringing this to a close, my honourable colleagues, there's time to measure benefits. Plant B, in moving to a Plant A, they could see the benefits in 1 to 2 years. Plant C, moving to a D or an A, probably no benefits for 5 years. And there's no opportunity for improvement once the organization is committed to a step change. So, ladies and gentlemen, I'll close now, and I'll leave to my honourable colleagues to continue. Thank you very much.
Thanks very much, Philip. While Jean-Francois gets set up, I'll ask Niels for his first impressions.
Thanks, Philip. I like the part about hiring consultants. Also, while Jean-Francois starts, I think he also has a very long operational background, so hopefully will give us some perspective from both the operational viewpoint and the technology step change viewpoint. As we said at the beginning, I'm not sure they're mutually exclusive.
Hi, everyone. So I guess that before I start on step change, I'm in a new role since the beginning of the year, and the first thing I did in that role was to implement an operation excellence strategy. So I think that the argument is not that we don't want operation excellence, but step change technology has a huge edge. And this example is coming from a new mine that Tronox is building in South Africa at the moment in KwaZulu-Natal. And I think that what I want to identify is on the left side of this, you have a picture of the smelter that we have. It's a titanium smelter in KwaZulu-Natal. And at the moment, that smelter has the worst financial performance of all the operation worldwide of Tronox. And that's because we need to buy the ore, and we don't have the advantage of the core revenue coming from having an integrated operation. And starting next year, when we will have complete the construction of the Fairbreeze mine, which is a $365 million investment, that operation will become the jewel of Tronox. So you could see what step change technology can do to an operation. Another example, that could be adding technology incrementally. And to achieve a theory of step change, it is also another option. And here you have an example, in the nickel industry. This graph shows increase in individual furnace power over the year. Look, of course, furnace power is proportional to the nickel production rate, and that's what you can see on this graph. But PT Valley have achieved a production rate per furnace of 3 times the initial rate by making a number of technology step change over the course of 35 years. The first technology step was the addition of the hatch cooling element, also a technology that I have experienced myself in the QIT furnace in Sorel, where we step change to increase. The second step technology was using higher voltage in the operation. And the most recent technology was the implementation of an improved control system that really allowed the furnace to run at 90 megawatt. I think that a point that is very important to make if you want to be successful with step change technology is to make sure that you do it the right way. And I'm not going to read all the elements that we put on the slides, but it's very important to get knowledge if you want to be successful. And enabling scale-up, is difficult. And when you go with new technology, you often have to go from pilot plant, to bigger scale. And it's difficult, but I'll share with you a very important insight, and I learned it when I did my thesis work at McGill under George Demopoulos. I don't know if he's in the room, but George has teach me a lot of things, but one important thing is there is a lot of information out there. Go and get it. And I can tell you, while looking for this conference, I found that someone wrote a thesis on enabling scale-up in the process industry. And I can advise you, if you have project to build a step change technology, this is a thesis from the University of Cambridge, and it has a lot of good insight. So take the time to learn and to avoid the mistake that other has done previously. I guess that if I'm talking about step change technology, it's because I was lucky enough early in my career to start as a research engineer and work on a new process and a new technology to upgrade titanium slag so it could be used by a different process in the industry. And that process is called UGS, for upgraded slag. We're not very imaginative, metallurgists with names, so that's the name we gave the process. And we went from 6 gram to 10 kilo, and then from 10 kilo to a ton, and then to build this facility that produced, at the time, more than 200,000 tons of capacity. And I guess that important learning when you go in step change technology is build a good team, make sure that you use the expertise of the supplier, make sure that you use the expertise of other people who have used similar process. But look, I wouldn't lie to you, there's no magic. If you can avoid a new process and a new product, this is the worst combination, because you have to prove everything. You have to prove your product on the market and prove your process. So if you can minimize the step change, it's always a better recipe to have normal working hours. I guess that this is another picture of that UGS plant. I think it looks better than the first one, which shows the UGS on the metallurgical complex. I guess another example that I want to share with you is what we just launched at our pigment facility in Hamilton in the US. Tronox has its biggest pigment plant there. And the plant is one of the lowest cost plant in the world, but we would like to improve that position. And one way to look at it is obviously to continue on the journey of operation excellence. And to me, operation excellence is something that needs to be done by everyone. It's the people in finance, in HR, in operation, in technology. Everyone needs to work on operation excellence. But you need to put aside a small team of people to who you give the task to really focus on step change. What can we do differently to really change the dynamic, change the position of the facility, and be sure that the plant will be there in the next 10 years. And we're launching an initiative with the help of Hatch to really try to step change how we can approach a growth of the Hamilton plant. And this is the start of, I hope, a long, successful journey to really step change the technology of that pigment plant. So I hope that I didn't convince you not to work on operation excellence. I think it's very important, but it's also very important to make sure that you have people looking at step change, because they make a huge jump in your success. Thank you.
And I'd just like to hear from Philip, his first impressions.
Well, Jean-Francois, it's just a coincidence, but Hamilton looks like Plant A. And I think you argued the case for us. But I don't know if there's any shareholders here of Plant A. There may be. But wouldn't you like to read in the annual report of Plant A, Company A, something like this? The report would read something like this. The EBITDA of our company increased due to operational improvements at Plant A in higher throughputs. You get your dividend and the share price goes up. So I think, Jean-Francois, thank you very much for introducing different versions of operational excellence. Thank you.
And now we'll hear from Mike Agnew.
Thank you, Boyd. Thank you, Jean-Francois. Good introduction for me. In light of the points raised by my honorable opponents, I would like us now to focus on some of the specific characteristics and possible outcomes of the alternative, operational excellence. My partner has described what operational excellence is and has described it as the prerequisite to evaluate options and to execute change. Let me add here that it is more than a collection of methodologies and management techniques. People in the field use specific words to describe the methodologies to achieve excellence. Some are listed in the right-hand column. They will also use various terms to describe the characteristics of an organization once it has mastered these methodologies. I've tried to show some of them in the middle column, line for line with the methodologies. You may take issue with some of the describers. Use your own experience and change it to what you would like. The point I would like to make is that these methodologies and these characteristics of the organization are rooted in the human traits of the employees, as shown in the left-hand column, once again, line for line. You cannot teach collaboration without having empathy. You can't teach accountability without having loyalty. These human traits are inherent and cannot be taught. For example, courage, wisdom, honesty. These are the basis of operational excellence. The management technique comes after. The characteristic of the Plant A that my partner described is that the right people were in the right position. It follows, therefore, that operational excellence, we need the right people on the job. The inability to recruit and retain the right people is a major risk to operational excellence. It has been my experience in our industry that there are very few wrong people, but it is common to see the good people in the wrong position. It is hard, but it is important to get this right before we can attempt a step change technology. I think everyone has already mentioned the expanse is more than the process steps. We also need to point out the operational excellence applies to all areas of the business, not just the process. Recruitment, of course, based on my previous slide, but also finance, as Jean-Francois mentioned, and my partner has pointed out that the use of the most appropriate technology is essential. My apologies to people who thought that we were going to argue against investing in technology. I'm showing here a slide taken with permission from Phil Thwaite's presentation in the Distinguished Lecture Series on process control in the context of operational excellence. That lecture takes place today at 1:45. From that, we can conclude that process control and operational excellence go together, so I don't need to elaborate. The chart describes how, when we move from poor control to better control, the variability of the process parameter is reduced. Once we have achieved this level of control, we can optimize the process. I would point out That the same is true for the business overall, but on a much longer time scale, years, not just minutes or months. Here we see a case study of a plant's operating results. The annual production, which is expressed as a percentage of the production in the final year, is shown over 23 years. The first 10 years are given as background. Starting in year 11, there were changes. Very few people left the organization, but there were position changes, organizational structural changes, and a lot of emphasis on priorities, alignment, and responsibilities. With stable operations, it was easy to define constraints. There were process improvements introduced, and capital was justified to debottleneck specific process steps. The results were in 2 stages, just like the process control example. First, stable, predictable performance, where potential areas for improvement could be identified, and then change implementation went smoothly. I could show other performance measures, such as recovery, over the same time period, but the story is the same: stability followed by improvements. Today, we have support for operational excellence in many areas. Analytical methods and thermodynamic models support process understanding. Advanced process control is supported by measurement instruments and by computer power. Management methodologies support complex initiatives. Let's take advantage of them. When we are considering options and changes, it is important to understand the drivers. The greatest competitive advantage to upgrading a long-life asset with retained earnings is the avoidance of debt burden created by a large investment in step-change technology. Today, this advantage is frequently lost through the downloading of debt onto the operator's balance sheet following mergers and acquisitions. When we read about post-acquisition write-downs and cost control initiatives, we ask, how many life-extending capital improvements were deferred? What has been the effect on staff retention? We see that these are 2 critical components for operational excellence and sustained competitive advantage. Loaded with debt and without the advantage of renewal, a Plant A can evolve over time into Plant C, too late, a candidate for step change. Still okay for time? Similarly, we should point out that operational excellence is burdened with a larger tax load than step-change plants. This is certainly not the intent of the tax system, but it can become the driver for or against change. The wrong driver, we believe. Many costs for labor that we show are actually costs of government. Perhaps when we consider options, we should break out cost of government as a group of costs. But we are not in the habit of calculating cost and value of essential government services for different options. To have the cost of government for an operation go down when investment improves productivity without increasing throughput seems misplaced. I guess I would argue for a value-added tax over income or payroll taxes, which are negative for employment. I would argue for a reduction in income taxes, but I don't know how to have that flow back to the employer as a reduction in labor costs. The discount cash flow calculation is often problematic for investments in operational excellence. Small improvements for the recovery of another byproduct can often extend the competitive life expectancy of a plant or move it from Plant B to Plant A. But these advantages are often heavily discounted by the calculation and cannot take into account the benefits of extending the competitive life of a business. In summary, then, we submit that operational excellence can be the right initiative to many circumstances, and with lower risk and debt load, offering multiple opportunities for innovation. In any case, operational excellence will provide a solid baseline to evaluate options and is essential for a smooth implementation of change. Thank you.
Thanks, Mike. I'll just ask Jean-Francois for some initial thoughts on Mike's talk.
I think that it's hard to debate that we need both, and that's what Michael has is in his conclusion, is you want step change technology, but you also want operation excellence. And I guess that let's try to bring a debate where what should we do to make sure that we can have both? You know, what are the key elements to make sure that all company and all plant in Canada could be like this plant A that our colleagues talked about, but with great technology that will make sure that worldwide they can compete. Thanks.
So I'll take a note from what Jean-Francois just stated and start the discussion off. I think we're concluding that, of course, both are important and the balance is important as well. But if both sides could maybe comment on what they would do if they could go ahead 10 or 15 years, how would both operational excellence and technology step change be implemented 10 or 15 years from now? What would they tell the next generation to do and not to do so that the future gets it right? Does someone want to start?
Lloyd? Well, thank you very much. We'll certainly get comments from the floor, but 10 years is not very long in this business. I'd say the first thing is to develop and retain good people. A company needs to have the best people, and they need to keep them. And the second thing is the skills of those people need to be renewed. We saw that Plant A encouraged people to go to conferences. It's a bit disappointing that some of the new owners of plants in Canada don't seem to have a big number of people at this conference, for example. So those skills may not be renewed as fast as they should be. And I think the third thing is, Boyd, to renew the assets, to introduce operational excellence. Just as Plant A, they had 2 innovations in the pipeline that they were going to be implementing in the next year. The people actively went out and sought new ideas. So renewal of the assets, even ahead of step change. If they do those things every year for the next 10 years, then the decade after that, they're certainly going to be successful.
Sure.
Just a slightly different view on that, of course. I think it's very comforting and sometimes a bit too easy to polish what we already have to make it better. That definitely needs to be done, but my advice going 10 years forward is to start thinking about technological step change now. It does take a long time to implement properly. As Jean-Francois mentioned, going from the 1 gram scale to the 10 kilo scale to the 1 ton scale to the commercial plant takes a long time and therefore has to be started now if it's going to happen in 10 years. Kennecott is a good example that changed from reverb furnaces to Noranda reactors in 1977, I think it was,
Yep.
And then in 96 to flash smelting and flash converting. Those aren't only for economic reasons, that was done for environmental reasons to be allowed to stay in operation. Each step had much better environmental performance than the former. I'd also like to add that we're not working in a vacuum. Certainly our colleagues in the Far East are much less afraid of new technology than we are, trying new things, and if it doesn't work, fixing it and getting on with life. I've experienced that in Korea and China particularly. So I think we too have to realize we're not working in a vacuum. While we obviously can and need to continue with operational excellence, we also work in a competitive environment and have to think about what others are doing and make sure we're technologically ahead.
Maybe on the 10 years, we talked about making sure that we can retain good people. It's true for operation excellence, but it's also true if you want step change technology. As opposed to operation excellence, I think that you can more easily get a group of people to convert a plant, and make it excellent. But with step change technology, you cannot buy it out. You have to work it out. You have to develop it by yourself. And that takes time. And 10 years is a very short period in going from an idea to realizing a project in our industry. And I think the advice is to make sure that you start investing in that step change technology many, many years before you need it.
Okay, thanks. We'll continue with a couple other questions, but if people want to get up to the microphones, and when I see that there's a group of questions, we'll flip it over to the floor. So don't be shy and come up. We'll do one more question, but when people are standing up there, if you could bear with us for a couple of minutes, we'll flip it over to the floor. So some of the discussion has come back to issues around financial management and how the financial side, the tail wagging the dog, I guess, deals with these kinds of larger changes, or versus a nice rise in your earnings that shareholders like to see. So what advice would you give the financial community? What background or what message would you want to give the financial community if you had them, and they would be willing to listen, I guess, is the other point. But if they were willing to listen, what advice would you give them?
Yeah. My advice would be think longer term. I think a lot of people in the industry will say, stop thinking about the quarterly results. My goodness, I think the discount cash flow calculation is too short a term for some of the initiatives that are required. So think longer term and keep the balance sheet strong, keep the operations well financed, and then we can continue to have operational excellence and reinvest in our business. But when the acquisition debt loads are downloaded onto operations, I think we're entirely moving in the wrong direction.
One piece of advice I'd like to give and would like to implement myself if I had the cash would be to invest counter-cyclically. Few large companies do that. They seem to all pile in when the price of one metal is particularly high. I've only seen it done once by BHP at Cerro in the 90s. They invested in doubling the capacity of that ferronickel plant while the nickel price was low, and it was completed just in time to make use of the rising price. The cycles are quite known and quite predictable, so I think there is an opportunity there that's not being grasped. The other piece of advice I'd give is to really look at new technology a little more in a disaggregated fashion. As I suggested, not all new technology is implemented the same way. If you look at it and see what the test work was done, what the team is like, then new technology need not be a financial burden. I think I showed some examples where it was of great benefit, either financially or environmentally or both. So I think a little more nuanced approach in analysis would be useful.
Thanks. So we have a few questions. We'll start the floor up. I think we want to get as many questions and comments as possible. So if we can have people state their name and their affiliation, we'll get some comment here, and the purpose would be for us to seed discussion, and we can take this after 10 o'clock and keep discussing. So we'll have some comment from here and move on to the next question. So let's start with the first one.
John Chapman. I'm actually a prospector and a space development person, but I came from placer development from the 60s and 70s and Minolta coal in the 70s and 80s. At the management and executive level, I worked my way up. And I think a case study is good, as you gentlemen have presented here. Placer development from the period 1964 to about 1980, stock split 14 times. In 1964, if you had one share at $25, you were receiving dividends. And when it split the last time to the 14 level, it was worth $36 and still paying dividends. Now that's a measure of excellent performance in the industry. And I was lucky enough to be there. And I'll have to say they always worked to excellence in the performance of its existing operations, but was always aware of the opportunities for step change. And they never took the step change until some of the risk had been taken out. I see too many people, like today I'm involved in the space industry because I wanted to get out of mining. I wasn't using the physics and math and chemistry that I'd had in university. It was getting boring. And in the space industry, they don't take a huge risk unless their vision in the risk, if it's fulfilled, has a big reward. And it's amazing the number of people I see that will do the opposite. They'll take on a step change that is potentially pretty good, but the risk is huge. So you always have to be measuring risk and reward. And I disagree with the gentleman over here on discounted cash flow net present value. Placer Development just drilled that into us all the time. But you weren't looking at just short-term discounted cash flow net present value. You were looking long-term. If you were going to put a downhill conveyor in, like for example, we took over the big conveyor system from the Peace River Dam at Gibraltar. It was the first in-pit crushing and conveying system. That saved the mine because at that time fuel costs were just escalating terribly. And we were able to diminish our energy costs by putting that conveyor system in. The other one is SAG mills at Gibraltar. It started up the same time as Highland Valley. And Highland Valley and Similco both went with SAG mills and had a horrible time getting up to nameplate capacity. Placer, on the other hand, said, no, we're not quite ready for that. Let's go with conventional rod ball. And lo and behold, within 1 week, they were up to full capacity. Now, they were rated at 25,000 tons a day based on the feasibility study and everything, but they achieved 33,000 tons a day within 1 week and never looked back. They have gone toward the end of their life before they were taken over by, well, they merged with Dome and then taken over by, who was it who took them over? Help me, somebody. What was it? Yeah, Barrick, that's correct. And it was all downhill. Like when they first merged with Dome, the shares never split again. And yet that 20-year period is one worth focusing on. Now, two things. With Minalta Coal, we were, in some cases, union-free. And I can tell you, union-free with everyone on staff. And even if they're not there, they still get paid, even though they're considered in most operations as hourly paid, and you shouldn't get paid if you're not there. That's the way to go. Empower your people to be part of the operation. And being union-free allows you to do that, but you have to be really good management, have to stay focused. Now, one other thing, and this is going to shock you. In the mining business, when I go to the different conferences, but I don't go to very many anymore, it's all gray hairs. Now, I notice a pretty good mix here. There's quite a few young people. I was shocked when I invested in the space industry 13 years ago, and I'm on a couple of boards, and I've made actually pretty good money in the space industry. The average age that we hire to is 27. No, I always thought I was over the hill at 40. Turns out I was over the hill at 27. Now, where does that come from? NASA, when Neil Armstrong set his foot on the moon, some smart human resources person said, I wonder how old the people are that got him there. And they found out it was 27. And that was a shock to most people. But now when you look at Dell, Microsoft, Intel, all of those companies, and you look, and SpaceX is a good example now, how old are the people that have created huge value for these companies that have taken them from a few $1 million to billions of dollars in net worth? Average ages, 26, 27, 28.
Thanks. Do you have something for them to chew on?
That's it.
That's it? Okay.
So you got lots to think about, folks.
Thanks very much. Nathan?
Yes, thank you. My name is Nathan Stabina from McEwen Mining. No one talked about the conservative nature of our business. You know, if you look at our industry, we're using 100-year-old technology, flotation cells, the ball mill, Pearsmith converter, and so forth. So if you compare our industry to others, you know, we're very conservative, and see if you have any comments on that.
I think that's true. I guess that comes from the huge investments and the scale. But I do think there are people changing, perhaps not so much in the West. I find that more in the East. At least one company changed their Pearsmith converters to top submerged lances. That's Impala Platinum, as I mentioned. But that's my point. I think we can't be stuck in the past completely, otherwise we'll get overtaken by competitors who are less risk averse than we are. I think it's been mentioned before that the risk has to equal the reward, but just to assume that all risk is to be avoided, we will stay stuck where we are with 100-year-old technology.
Well, I agree with my colleague, I guess. Yes, we do use old technology. It might have to do also with the timeline to development. We talk about the space industry. My goodness, they have these tremendous budgets for 20-year programs. It's difficult with a cyclic industry like ours to maintain an initiative like that. I think that has played against us for the last, generation at least.
Okay, thanks. Pascal?
Hello, I'm Pascal Coursol with 5N Plus. I have a question maybe for Mr. Turgeon. We heard some example of the UGS, which is an amazing success in the industry. We heard also an example from Koniambo that is a great success, also I think process-wise in terms of step change. And now we see in Canada the corporate R&D or strategic R&D funding has been greatly reduced in the last 10 years, and a lot more R&D has been made in China. So, where do you think we should go?
Look, it's always a challenge to justify putting money in R&D, but to me, this is the most critical place to invest if we want to remain competitive. And I think that, to your point, our business is cyclical, but the last place you want to cut when you're at the bottom of the cycle, and believe me, I hope we are at the moment, is to cut in R&D. In fact, your R&D is the area where you cannot, in good cycle, when you make piles of money, and that happened in our business, you cannot suddenly spend more in R&D and expect a proportional return from that investment. You better invest with a stable base in R&D, but if you kill it in down cycle, you destroy your business. So the advice would be, to be successful, is we need to invest in R&D. And yes, it's difficult, but if we want to have successful business, we need to believe in it. And I guess that showing example of company who have done it successfully is probably the way to convince people that that's the best way to do it.
Philip?
Mr. Chairman. Thank you, Dr. Coursol. I'd like to add a few comments. People do benchmarking all the time. Now, if a benchmarking was done against Plant A, their costs are very low, their plant is running extremely well and it's profitable, then you'd emulate what they're doing. You would, if you were smart, do some R&D yourself. And I think around the Western world, I hope there'll be a swing to renewed investment in R&D. There's things that we can do, have joint ventures with plants in the East, and get onto R&D in a different way. But I think you're right, Dr. Pascal. If the R&D is not done in the West, then the plants in the West will probably close, which would be a shame. We're not there yet, and I'm optimistic that things will turn around.
Thanks, Philip. The next is Jeff, I think.
Hi, Jeff Donald from SNC-Lavalin. I was involved in a benchmarking exercise a few years ago that looked beyond comparing just base metal smelters and comparable peers to other industries like aluminum, cement, mini mills for steel and this sort of thing. And what we found was that the operating factor in aluminum and cement was much higher than it was in base metal smelters. And I'm wondering if you accept this conclusion, why that is and what we might be able to do about that.
Mike?
Yeah, good point. I accept the conclusion, definitely. I think we should first start looking at the cyclic nature and how the people were retained. I think it all comes back to people and dedication, long-term focus in order to achieve these things that they have in the aluminum industry and the cement industry. They didn't happen by themselves. They happened with investment and dedication and people with a vision and people who were able to execute, and they're reaping the benefits for sure.
There's a comment in the National Post today about Mr. Branson, and the headline is that companies need to take more chances, more risk, and be innovative. And I think that's Mr. Chapman with the comment about risk and reward probably needs to be looked at in more detail.
I just wanted to add that I'm not sure operating factor is designed into plants to the extent it should be. Sometimes we design very complicated plants with 6 unit operations in series and no storage in between. So if you multiply 0.9 to the 6th power, you get a pretty low number. And that sometimes happens. I think we do have to look more strategically at designing plants to put the bottleneck in a known place from the beginning and to decide where you can have storage. That certainly helped Kennecott a lot, to use that example again, by decoupling smelting from converting. They can store granulated matte before it goes into the flash converting furnace. That obviously helps overall operating factor.
Thanks.
I think I agree with your remark. That's the reality. That's the fact that we can see. I guess that what can explain it is probably the fact that when you have a step change technology, I mean, you are in an area where for a short period of time you have a huge advantage and you beneficiate from that advantage. It's an excuse because, I mean, it would be much better if on top of it we would optimize our process and put the best practice in place, but you're not forced to do it by the competitive pressure. And that's probably what explains why, in some case, it wasn't done.
Okay, thanks. I think the next up was Enzo.
Enzo Palumbo, BBA. This question is directed to Michael Agnew. And it's going back to the McNulty curves. You didn't talk about the McNulty curves in debating the step change technology. Step change is difficult enough, but if you add some new technology features to it, it'll take a long time to ramp up. Do you have any comments on that?
Yeah, thank you. Thank you for the question, yes. I would say when it comes to implementing step change, a lot of people would say the best time to do it is when you're building a greenfield plant, and it's also the worst time to do it. Personally, I would like to see step change technology introduced at a brownfield, where you have all of the infrastructure and support services in place, starting up a step change technology with a new plant to start up at the same time, where you're worried about procedures and just getting the parts warehouse working is very difficult, puts a lot of stress on the people. So if you could introduce your step change technology when all of those services exist, and then just when you build a greenfield plant, essentially copy, I think would be the best case scenario, and that would limit your risks and make it a lot easier on the project people. So you would be then in a greenfield plant, you would be in I think it's a type 1 according to the McNulty curves. So operational excellence would be at the brownfield, not at the greenfield.
Look, I would certainly support Michael's point, because when you have a greenfield site, if on top you had a new technology, there is a lot of research that talk about process issue in step change technology, but there's also a lot of information about people issue in startup and greenfield site. And if you have a brownfield operation where things are already established, you already have good communication system, people know each other, you eliminate the people issue from the process issue. And some step change technology has failed because of the people issue. So if you can manage this risk out, it's one less risk of failure.
Okay, thanks. I think we're over here.
Yeah, Ian Cameron from Hatch. Question to Nils and Jean-Francois. In developing a step change technology, one of my opinions is you need the entrepreneurial spirit, and you need that, God, we got to do this. And one of the contradictions I see is very large multinational companies, very large projects. How do you get the entrepreneurial spirit?
I think it helps to have the inventor on board. The inventor typically wants to see his or her invention commercialized. I think that certainly is important, but I've often seen the opposite problem, that the inventor is blind to all these issues that need to be solved. So I think having a good balance, you certainly need an entrepreneurial team, but you need almost a debate like this, where you have a good balance of champions and skeptics to make it really work. So I think if you have all skeptics, obviously nothing happens. But if they're all champions, they can charge off in the wrong direction and get persuaded by their own propaganda and build something like the earlier gentleman alluded to that has a very small reward for the huge risk. So I think a balance is required.
Maybe one way that I have seen work is you need to have a good stage gate approach to how you deal with your project. At the early phase, you really want that, well, call it crazy spirit, where any idea is worthwhile looking at, any idea is worthwhile exploring, and you really need a creativity element, and that entrepreneur activity, and that you create that with some structure, around. But as you move toward realizing a project, when you start dealing with the engineering firm, you better have some skeptical, that have tell you if your idea is good or not, because then it starts to cost you a lot of money. So that's how I would do it.
So we'll be redesigning our offices like Google.
Well,
That'll help attract some 27-year-olds.
If I can weigh in on this for 2 cents, I've done my whole life is process development work, and we see people who are wide-eyed and excited about some chemistry or some physical thing or some spark, and they get sparked by this, and that's great. But they spend too much time focused on this one element without looking at the big picture early enough. You can put a very basic CapEx, OpEx, you can look at the numbers, you can put this down with very big ranges. You can look at a sensitivity of this and say, we don't understand this and this and this, so let's go into the lab and figure that out. Instead of just focusing on this one issue that you've sparked the process with, you have to look at it in its entirety across the entire process. And we just see this time and time again, just not done. It's too narrowly focused. Alessandro.
I have first a comment to offer about step change technology, and then another one about operational excellence. First, for the step change approach, and maybe this goes a bit towards the general framing of the conversation, we should see that the word stepwise, step change, is in fact conciliatory. We're talking about almost on purpose trying to suggest that we're talking about low risk, and so we may think about step change as opposed to complete re-engineering. And I would just say, if somebody said that the move to flash converting, for instance, at Kennecott, if that's a step change, well, you know, that's actually, you know, maybe we're underselling the amount of innovation there, because, you know, these kinds of things are actually, you know, re-engineering based on new concepts. And so I offer this comment to distinguish between a step change and a complete re-engineering. I would say a step change, we're talking about a change in the process where we can still have a mode of operation that works with similar feedstock, however open perhaps new modes of operation, and therefore as conditions and as supplies of different ores and so on change, you know, the plant is well positioned to dominate the new approach. No. So here I say step change, and I'm just suggesting this. Step change may be a change that still gives access and perhaps a competitive advantage to existing feedstocks. And so again, we should think about step change versus re-engineering, because indeed sometimes what's necessary is a complete re-engineering. We wouldn't want to fall behind, for instance, to say a more innovative spirit because we're sort of constrained to the idea that we don't want to take risks. That's what we're talking about with step change. And well, anyways, that being said, I just want to comment now about operational excellence. Operational excellence, you know, we're now in 2014. If there are producers here that don't have some kind of a system to capture innovation at all levels of operation, I think that that's a real shame. I mean, these aren't new concepts. Many of them were pioneered in North America, and it really speaks to an interdisciplinary divide. If we've got companies that don't have a notion of operational excellence, actually there's no excuse to have, you know, to be without a system to capture operational excellence. And obviously, these two aspects that we've discussed are not mutually exclusive.
Thanks. Niels, do you have a comment?
Right, thanks.
Yeah, I think certainly the language can mean different things to different people. By step change, we didn't mean incremental change. We actually wanted to highlight that it was a significant change, like moving to flash converting, like changing from Pearce-Smith converters to top submerged lance converting at Anglo Platts. So certainly we agree on this side anyway that significant change is what we're talking about.
Mike, go
ahead. From our side, we discussed the possibility of having operational excellence measuring tool similar to the McNulty curves type 1, 2, 3, 4, and decided it would be too complex of a concept to introduce in the time limit we had. So we'll leave that for the next publication, someone who wants to go around and benchmark plants and come up with a measuring system to see just to what extent operational excellence has been introduced. I'll just share an experience with the McNulty curves. I've been invited to do quite a lot of stage gating of projects, and quite frankly, it's not helpful, the McNulty curve sometimes, because absolutely every project I was invited to was a type 1. You just had to ask the project team. Nobody thinks they're doing a type 2 or 4. You just can't convince them. These are not independent measurement tools, and that would be a big help for operational excellence. Everybody thinks they have it. Maybe they don't.
Philip?
Yeah, Mr. Chairman, yeah, I'm sure everybody in the room are wondering, well, how do we put this into practice? I mean, if you visited like we did this summer, visited a number of plants, they're not all plant A, and they should be. So I'd just like to make a few comments that, well, you have to have the buy-in from the company, from the president, from the CEO, from the CFO. They have to buy into this. But it doesn't need to have bureaucracy. Everyone is very, very busy these days. If you talk to anyone, people at the plants are very busy. There are a number of good books on the subject. We've got some lists of books. There are consultants. I talked about consultants. Neil, I argue that people these days probably need to have the right consultant at the right time, and it's an investment and there's a payback. But it doesn't need to have a bureaucracy. And I guess the other thing is, look at what other people are doing. Go to the plant A and see how good they are and see how they do it. And also go to a plant C and just see how did they get to where they are now? And there are a few plant A's in Canada, in the US, and there's a few plant C's. So I just offer those little suggestions to how do we get to what we want to be.
Thanks, Philip. We've got 3 people on the floor. We've got 7 minutes. So let's try to get everybody finished up here. So we'll go to the back here, please.
Okay, Victor Hernandez from Hatch. I just have a question more related to, as it was discussed, R&D needs to be supported, but at the same time, the resources are limited. And there are many possibilities for a change in the plant and investing. So now, some of us, we may be involved in trying to make a decision, perhaps, on the different alternatives of technologies. There are smaller changes, big changes, complete changes of processes. So if we're to think in terms to where to look at investing our R&D effort and money, with respect to the methodology, what would be what you consider the main criteria to look at, say, okay, maybe a technology almost already developed and invest more in it to bring it up? Where do we invest in more fundamental, bigger type of change of the business that we keep it going for the future 20 years, 30 years or so? Any of your thoughts would be appreciated.
Look, I'd like to reinforce what Boyd said earlier, is when you have that difficult choice to make between traditional way of doing something or a small step change, as explained earlier, or a complete re-engineering of how you tackle a project, I think that you have to do a financial analysis with the whole picture, and then you could see if the risk-reward works moving away from something that is already known and works and has been proved. So that's how you would assess how to make that decision.
And this is not done very often.
Yeah, absolutely.
It's shocking.
Yeah.
Yeah.
It's so obvious, but people don't do it.
It's really, yeah. People don't, I think in part, engineers don't want the money guys to come in and tell them not to do their project, right? So they keep things apart. Over here. Well, yeah, in front.
Hi, my name is Roberto Pinto. I work for Rio Tinto Iron Titan. I actually work at UGS plant that Jean-François showed. And my question is more for Jean-François and you, because my question is more about the cost of new projects. Do you actually see a difference between the final cost of a new technology with the initial cost, or is sort of the same as the cost of technology that we know? When you start a project that is known, you sort of like can gauge like how much it's going to cost at the end. But of a new technology, did you see the costs were similar, or they exploded with the project?
Well, I guess that when you start a new project, you have expectation on costs, and you assume a certain price for natural gas, you assume a certain price for electricity, labor, and all that, and then you add up all of that, and that's your estimate. When the reality hits and you start producing, sometime you realize that there was a huge mistake in one area, but as long as the financial is robust enough, the mistake in one area could be compensated for nice surprise in another area. In the case of the UGS, I guess that the product was so good that it was able to compensate for the extra costs of producing it. I guess it's still not easy today for UGS, but that's when you compete with nature, it's always hard, because the reality is UGS compete with natural rutile, which can be extracted out of the ground for $200 a ton, as opposed to doing it with all the step of mining, smelting, and then metallurgical process. That's always hard to compete, but still, it's a product that has its place in the industry.
Okay, thanks. One more, Jan. You're the last one here.
Last one. Sorry. My name is Jan de Bakker. I'm with Air Liquide Research and Development. And I have a question to the board about research funding in particular. We've mentioned earlier that the research funding for new developments tends to be cyclical with the market. And we've also, people have mentioned before, okay, we need to have better funding we need to have more sustained research funding, we need to have long-term funding, we need to have sustained research budgets. Who is we? I mean, in that sense, what is the best research funding mechanism? Should it be 100% industry? Should we retain the industry government co-funding model, at least in Canada? Should mining companies be forced to pay a certain amount into a research and development fund, which happens in some countries? I would love to hear your comments on that.
Well, you know my answer. I'm a bit biased, so I'll let the others. I'll let the others answer, I guess. Do you have a?
I personally like the industry and government model. I think if government funds it alone, you can get off track, and to have industry buy-in, literally by co-funding, is a good way of doing it. Unfortunately, it really is cyclical. I think there are some, I don't think, there are some new initiatives here, the Canadian Mining Innovation Council and others who are setting research priorities. I think our government has finally figured out that research and staying ahead in technology is a competitive advantage for Canada, and some of the tax dollars that the mining companies pay should be reinvested in that. I think to do it by force, though, is a bit dangerous. It assumes that input equals outcome. Just because you fund it, you'll get good results, which may not be true. That's why I think it needs to be co-funded by industry, who have a more dollars and cents view of it perhaps than others. So my take on it is that the co-funding model can work. It just has to be funded to a larger extent than it is now. And I think the market does have a way of self-correcting. Underinvestment in R&D will catch up and create more Type C plants that will become apparent, and people will have to do something about it, hopefully before it's too late.
So, Mike and Philip, you have a pithy last.
Okay, a lot of questions about research. I think the best model is to have the user contribute and therefore be committed to the development. And just a personal experience, I think at one point Jean-Francois mentioned having a separate team for step change, and I have nothing against that, but I have experience where having that step change research and development team closely tied back to ongoing operations.
And I didn't mean away from the plant.
In fact, the ongoing operations benefit more. We stopped the step change technology, but we got millions of return by cross-fertilization from the step change research.
Philip?
Yeah, just a quick comment. I think industry does need to support more research and development in the West. I think it's a dismally low number if you compare it to other industries. But I also agree with my honourable opponents that a kind of a shared thing, a shared arrangement, is also a very good way to do it.
Thanks. So. I concur that more research funding is needed in the West. That would be a great thing for everybody. Well, thanks. I'd like to thank the 4 speakers for the plenary session. Hopefully this conversation can spill out in the hallways, and we can have some step changes along the way from it. So now we have a short break, which is a little shorter than I had planned. And after this, at 10:15 downstairs, the risk management roundtable run by the management metallurgy section. This is not co-programmed against technical stuff for the first hour at least. So No longer is there the excuse that I couldn't make this one because I had to go to a technical symposia. So I hope to see a lot of you down there. And at the same time, there is the role of Extractive Metallurgy Society's meeting, which is next door here. That's at 10:15. So you have a choice of those two, and as well, the poster session is on if you want to walk around the hallways, and the trade show is open as well. So thanks very much for the morning. I hope you'll have a good rest of the morning, and we'll see you throughout the conference. Thanks.
Well, thanks, Mike.